this review, we'll be going over limits. More specifically, we'll be computing limits. We'll be doing this by just doing a few examples. The first example, we'll have f of x is equal to the quantity of y minus 1 times y minus 2 over y plus 1. And we're asked to find the limit as y approaches 2 from the left of f of x. Now, using a theorem that can be found in the chapter of this book, we can split up this into the limit as y approaches 2 from the left of y minus 1 times the limit as y approaches 2 from the left of y minus 2 all over the limit as y approaches 2 from the left of y plus 1. Now, within these three different limits, we can notice that there's really no problems that we wouldn't be able to get a value out of them, so we can just plug in 2 for y. So we'll have 2 minus 1 times 2 minus 2 over 2 plus 1, which is equal to 2 minus 1 is 1 times 2 minus 2 is 0 over 2 plus 1 is 3. Because of that 0, the whole thing is going to be 0. So the limit of f of x as y approaches 2 from the left is 0. The next example we'll be doing another one. So we'll take f of x. This time f of x will be equal to x squared plus 6x plus 5 over x squared minus 3x minus 4. And we're asked to find the limit as x approaches minus 1 of f of x. Now we'll do similar to what we did in the last problem and split the limits up as the limit as x approaches negative 1 of x squared plus 6x plus 5 over the limit as x approaches negative 1 of x squared minus 3x minus 4. We'll carry through the negative 1, so we'll have 1 squared minus 6 plus 5 over 1 squared minus plus 3 minus 4, which gives us 0 over 0. Now, if we look at one of the theorems gone over in this chapter, we'll go say that 0 over 0 is a case where the limit does exist. If this 0 was a different number, then the limit would not exist. But since this 0 over 0, that means we have a limit, which means we have to try to simplify this fraction in order to get rid of our denominator, or to get rid of the denominator that's causing our problems at x equals negative 1. So what we're trying to do is we'll try to factor. First we'll set up our limit as x approaches minus 1. This time we're going to try to factor both the top and the bottom. We can factor the top of x squared plus 6x plus 5. We'll factor up into x plus 1 times x plus 5. In the bottom, we'll factor x squared minus 3x minus 4 factors to x minus 4 times x plus 1. Now, if you notice, we have a similar thing at the top and at the bottom. We can cross the two of those out and go back, and now all we have is the limit as x approaches minus 1 of x plus 5 over x minus 4. If we insert the minus 1, we have minus 1 plus 5 over minus 1 minus 4. So we have minus 1 plus 5 is 4, over minus 1 minus 4 is minus 5. So our final answer is minus 4/5. We'll be doing one more example. This one, f of x is equal to x over x minus 3. The first thing they ask for is the limit as x approaches 3 of f of x. Now, just like in the last two problems, we're going to split the ratio up into with the limit as x approaches 3 of x over the limit as x approaches 3 of x minus 3. Now, if we place in what we have, place in 3 for x, we'll get 3 over 3 minus 3, which comes out to 3 over 0. If we look in this chapter of the book, we'll find that 3 over 0, or any number over 0, will indicate that the limit does not exist. So if you ever do that first step, and you get a number over 0, and you're computing the limit from both sides, you don't have to go any further because the limit does not exist. The next thing they ask us is the limit as x approaches 3 from only the positive side of f of x. It becomes a little more complicated. So now what we'll do is we'll do what they call a sign line. So we'll draw a line and put on this line 3. It's really not a 2 scale, but it really doesn't matter. We're just worried about the sign of the graph on either side. So what we're going to do now is we're going to try to find whether this side is positive or negative, what the sign of this side is. So we're to the less of 3, so let's just try 0. Or we can try 1, will give us a little bit easier numbers. So we'll have 1 over 1 minus 3. So that's a positive number over 1 minus 3 is a negative number. So positive over negative is a negative. Now over here, let's try 5, because it's greater than 3. 5 over 5 minus 3, so that's a positive number over still a positive number, so positive over a positive gives us positive. Now what this is really representing is I'll draw a little bit of a not to scale drawing. So we have 1, 2, 3 right here. And what's happening here is we have this graph coming down like this, and this graph coming up like this, right at 3. We're worried about coming from the right because of that positive sign, so we come up, work our way up to the right, and just keeps on growing and growing until it gets to positive infinity. So the limit as x approaches 3 from the right of f of x is equal to positive infinity. I hope this lesson in limits helped you out, and I hope you come back to the next one.